supernova, death of a giant. The entrails of a star up to 100 times the mass of the Sun splatter across space. But out of catastrophe comes regeneration. From the debris, new stars are born. They fire up in regions like this, clouds of gas and dust, nebulae enriched by the supernova. For the blast carries metals like iron and gold, heavy elements spawned only in the most massive stars. Thus does a supernova seed its offspring. In this birth, a cloud of debris collapses under its own gravity. It forms a disk. At the center, a star begins to shine. Around it, rings emerge, rings that resolve into planets. Our solar system evolves this way. Earth orbits comfortably in the blue habitable zone, where life is possible. A rain of comets brings us water. Lightning is possibly the catalyst for life. Our early atmosphere is thick with carbon dioxide. But Earth is a beneficiary of that supernova. We're rich in phosphorus and sulfur, elements essential to living cells. As those cells evolve into higher life forms, green plants breathe oxygen into the air. Earth becomes the perfect incubator for life, neither too hot nor too cold. We're at just the right distance from the Sun. The same can't be said of Mars. It's a freeze-dried desert where, even on the warmest days, temperatures barely top zero. For Mars lies just beyond the habitable zone. Yet, less than a century ago, some astronomers believed in Martians, a civilization that dug a network of canals to carry water from the poles. Alas, those imaginary channels never irrigated a green planet. But Mars may once have had oceans and just possibly microbial life. The oceans disappeared, it's thought, because Mars is so small. Weak gravity allowed the atmosphere to leak into space. Stripped of its warming effect, the red planet froze. Today, the polar caps are a visible remnant. But many scientists believe vast reservoirs of water lie frozen beneath the surface. And who knows, microbes may survive there, or at least a fossil or two. But if we find new life in the solar system, it's most likely to be here. This is the extraordinary surface of Europa, a satellite of Jupiter. A little smaller than our moon, Europa is entirely covered in water ice. It may be tens of kilometers thick. This pack ice on Earth looks remarkably similar. And beneath it lies an ocean. If Europa's the same, great seas may wash under the icy crust. And they could be warm, heated by volcanic activity. As in oceans on Earth, hot vents may support primitive life, organisms that feed on chemical rather than solar energy. Europa must be explored. Onward and outward. We're now so far from the heat of the sun that no life could possibly exist. We've reached Saturn, where the temperature of its cloud tops is minus 180 degrees Celsius. But the gas giant isn't our quest. We're headed for Saturn's largest moon, Titan. Titan is a laboratory for the origin of life. With a surface temperature of minus 200, it's an unlikely place. But Titan's cloudy atmosphere has lots of hydrocarbons. They react with ultraviolet light from the sun. Photochemical reactions produce organic molecules. Such carbon-based compounds are the first stage in the generation of life. But Titan's too cold to go the next step. Titan is like Earth in deep freeze. The atmosphere, like ours, is rich in nitrogen. It contains water molecules, here in blue, a legacy of comets. The ingredients of early Earth are present. To come alive, all they need is heat. They'll get it 5 billion years hence, when the sun swells into a blazing red giant. Since 1983, this dish has listened out for extraterrestrials beyond the solar system. We've sent messages with the Pioneer and Voyager spacecraft, but from the stars, there's been not a peep. Nevertheless, evidence mounts that other stars have planets. Among them surely must be an Earth-like world. Such planet-forming stars are born in nebulae like this, clouds of gas and dust that pervade our galaxy. The excitement for astronomers is that these clouds contain the building blocks of life. They have water and organic molecules. As a star forms at the heart of a collapsing cloud, so the disk that emerges spins its center clear of debris. That debris makes planets. Here's a real star with a protoplanetary disk. And another, both pictured by the Hubble Space Telescope. This animation is of the star Beta Pictoris. In the clear center of its disk, a planet orbits. We may not be able to see a planet, but we know it's there because its gravity tugs on the star. The star wobbles. Astronomers detect the wobble by means of the Doppler shift. The star is blue as it moves towards us, red as it goes away. This Hubble image is a puzzle. It shows a pair of stars that have apparently ejected a planet. A trail leads us to it. Is this the first direct view of a planet outside our solar system? This one isn't a planet, it's a brown dwarf, with up to 50 times the mass of Jupiter, but too small to be a star. So far, of stars discovered to have a planet, none could support life. This planet has too close an orbit. The problem with this one is too distant an orbit. But when we do find an Earth-like planet, it's bound to be weirder than we ever guessed.